The process known as plate tectonics occurs during continental drift. This example shows two large segments of continental crust colliding very slowly over millions of years. One land mass is forced underneath the other. To relieve the stress, mountain ranges are often formed in the overriding land mass, while earthquakes
A tremendous amount of energy is released in the form of tremors.
That wound arose because the African plate lies above a huge plume of magma that's slowly melting the crust, causing it to stretch or rift. On the edges of warmed rock, high shoulders,
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways.
An unexpected movement of the Earth's surface is called an earthquake. When two parts of the Earth's surface move suddenly in relation to each other along a fault line due to tectonic forces, an earthquake occurs. A tremendous amount of energy is released in the form of tremors and vibrations. Such earthquakes are called tectonic earthquakes. The point of origin of an earthquake is called the focus, while the point directly above it on the surface of the Earth is called the epicenter. Owing to the strong vibrations around the point of origin, the degree of destruction is greater around the epicenter. There are three types of seismic waves that spread in all directions from the focus. They are compressional waves are the first to reach the earthquake recording station as they travel 1.7 times faster than the shear waves and are therefore called primary or P waves, while the shear waves are called secondary or S waves. Primary waves cause the particles of rock to vibrate forwards and backwards in the direction of the waves. Secondary waves, on the other hand, cause the particles to oscillate at right angles to the direction of the waves. When P and S reach the surface of the Earth, they get converted into L, long waves that travel along the surface, vibrating horizontally at right angles to the direction of the waves called love waves or Rayleigh waves, as they also travel like sea.
Emily is holding one end of the slinky, while Dr. Zook is pulling its other end towards himself, and then pushing it towards Emily. Watch closely, and you will notice that some of the coils crowd close together, and then slowly move farther apart. This is because the vibrations are parallel to the direction of the wave. If the wave is holding one side of the slinky, while Dr. Zook is holding the other end. With a quick upward flick of the wrist, Dr. Zook has sent energy traveling through the slinky. Notice how the slinky moves? This is a transverse wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. The wave traveled from Dr. Zook to Emily and back. Now let's see what a longitudinal
or S-waves. S-waves are elastic shear waves that move material sideways at right angles to their direction of travel. Because secondary waves travel only through solids, they do not penetrate the Earth's outer molten core. For this reason, there is also an S-wave shadow zone. The slower seismic surface waves do not penetrate the Earth's interior, but follow the surface. One type of surface wave, the love wave, travels in a circular motion and causes damage by displacing materials horizontally. Love waves can be very damaging. This cracked pavement and these twisted railroad tracks clearly demonstrate their destructive power. Earthquake damage also results from Rayleigh waves, surface waves which deform materials vertically.
Spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere.
One of the Earth's most intriguing mysteries is the presence of a huge arc of geological destruction surrounding the Pacific. It's known as the Ring of Fire. 3/4 of the Earth's volcanoes are situated here, and 90% of all earthquakes also occur along this line.